friends, welcome to video lecture on centrifugation, a gateway for breakup. Centrifugation is a separation and purification of biological molecule in a liquid medium under the applied centrifugal force. Separation is based on size, shape and density. It is a key technique for isolation and analysis of cells, subcellular fraction, supramolecular complexes and isolated macromolecules such as proteins and nucleic acid. The timeline of centrifugation. Here are some of the scientists who made contribution in this field. Swedberg invented the analytical centrifuge, and in 1926 he won the Nobel Prize for his research on colloids and proteins using. Well, if we discuss about the basic principles of sedimentation, every particle in a suspension has a tendency to sediment due to Earth's gravitational force. The rate at which given particle moves downward is proportional to the centrifugal force, which is directed radially outward and represented by following relationship, that is G is equal to omega square r, where G is the applied centrifugal force, omega is the angular velocity and r is the radial distance from the axis of the rotation. Angular velocity can be expressed in terms of revolution per minute, that is RPM, which is a common way for denoting centrifugal speeds. Omega is equal to 2 pi into RPM upon 660. By substituting above equation in equation 1, G will become 4 pi square into RPM square into R upon 3600. The applied centrifugal force is calculated in terms of multiple of Earth's gravitational force, that is G is equal to 981 centimeter per second square. This is referred as a relative centrifugal force and can be derived from equation 3. RCF is equal to 4 pi square into RPM square into R upon 300 and 600 multiplied by 981. The equation 4 on simplification becomes RCF 1.18 into 10 to the power minus 5 multiplied by RPM square multiplied by R. This is a simple way to express the relationship between RCF and RPM. This figure shows nomogram for determination field for given rotor speed and radius. Let us also discuss about few more relationships. Sedimentation velocity is the rate of a sedimentation of a spherical particle in a liquid medium will depend upon its mass, density and viscosity of a medium. The net force F is given as the following equation. F is equal to mass of a particle difference in the density of a particle and media, or F is equal to 4 upon 3 pi r cube p as rho m omega square r, where 4 upon 3 pi r cube is the volume of a spherical particle or radii. Rho p is the density of a particle, rho m is the density of a medium, and r is the radial distance in centimeter, and omega is the angular velocity in radians per. Traveling through the medium, particle also has to retard its movement and its any given velocity. The opposing frictional force will be given as F naught is equal to V multiplied by F, where V is equal to velocity of a sedimentation rate of a particle and F is the frictional coefficient of a particle in the solution. The magnitude of frictional coefficient depends upon its size, shape, hydration and viscosity of a medium. The frictional force for an unhydrated spherical particle is given by the following relationship. F is equal to 6 pi eta Rp, where eta is viscosity of a coefficient of a medium, Rp is the radius of a particle, and substituting the value of F from the equation 6 into 5, F naught will be 6 pi eta Rp V. On application of centrifugal force, till the net force of sedimentation equals the frictional force resisting its motion through the medium, F is equal to F naught, that is equation number 8. Putting the value of F from the equation 7 and F naught from the equation 8, equation will become 4 upon 3 pi r cube p multiplied by rho p minus rho m multiplied by omega square r equal to 6 pi eta rpv. The balancing of opposing force is attained quickly and soon the particle sediment at a constant velocity. The particle does not accelerate anymore and sediment at a constant rate. The rate of a sedimentation of a particle then is defined by the following equation, that is sedimentation velocity is equal to dr upon dt is equal to 2 rp square multiplied by rho p minus rho m multiplied by omega square multiplied by rho p upon 9 eta. This is the way how we can calculate the sedimentation velocity if we know the radius of a particle, density of a particle, density of a medium, omega and viscosity of a medium. When designing a centrifugation protocol, following factor could play an important role. The more dense biological structure is, faster its sediment in a centrifugal field. The more massive particle is, faster it moves in the centrifugal field. Denser the biological buffer system is, slower the particle will move in a centrifugal field. Greater the frictional coefficient is, slower the particle will move. Greater the centrifugal force is, faster the particle will sediment. So these are the factors which influences the when designing a centrifuge protocol, following factor could play an important role. More dense biological structure is, faster its sediment in a centrifugal field. More massive biological particle is, faster it moves in a centrifugal field. Denser the biological system is, slower the particle will move in a centrifugal field. Greater the frictional coefficient is, slower the particle will move. Greater the centrifugal force is, faster the particle will sediment. Requirement of centrifuge differs according to maximum speed at which biological specimens are subjected to increased sedimentation, the presence or absence of a vacuum, potential for refrigeration or general manipulation of a temperature during the centrifugation run, maximum volume of a sample or capacity for individual centrifugation tubes. Types of centrifuge. Different types of centrifuge available: large capacity, low speed preparatory centrifuge, refrigerated high speed preparatory centrifuge, analytical ultracentrifuge, preparative ultracentrifuge, large scale clinical centrifuge. Here are the different requirements or characteristics of preparative benchtop centrifuge. It operates up to 3000 to 7000 G, adaptable with different types of containers. For instance, tubes can be accommodated, even 96 well ELISA plates can be accommodated, and useful for many high throughput biochemical assays. High speed refrigerated centrifuge operate at up to G. It is used for sedimentation of protein precipitates, large intact organelles, cellular debris derived from the tissues, homogenization and microorganisms. In order to harvest yeast cells or bacteria from large volume of culture media, high-speed centrifugation may be used in continuous flow mode with the zonal rotor. Centrifuge operates up to 9 lakh G. To minimize excessive rotor temperature, chamber is sealed, evacuated and refrigerated. Modern ultracentrifuge can be started even without fully established vacuum or will proceed in the evacuation of a rotor chamber during the initial acceleration process. It is used for isolation and purification of sub-complex or multi-protein complexes. These are the details for analytical ultracentrifuge. Here, it can be used for real-time evaluation using optical detection system. For instance, ultraviolet light absorption and inference optical refractive index sensing sensitive system, which is widely used for determining sample purity, characterize assembly and disassembly, mechanism of biomolecular complexes, determine subunit psychometrics, detect and characterize molecular conformational changes, measure equilibrium constant and thermodynamic parameters for self and hetero associating system, thermodynamic and hetero. This slide shows how There are different types of rotors available. One of them is swinging bucket rotor. The rotor holds the tube in a vertical position where centrifuge is at rest. Tube moves to the end and remain in the horizontal position when rotor is in the motion. It is useful when samples are to be resolved in a density gradient. It is relatively inefficient for pelleting. Fixed angle rotor is widely used. Keep the tube at a fixed angle, that is 25 to 52 degree, to the vertical axis of rotation. During centrifugation, particles move along the side of a tube to form a sediment that pack against the wall. The surface of a sediment in this case is parallel to the shaft of the centrifuge. Here we can see that rotors and sample tubes are held in a vertical position during the rotation. This type of rotor is more efficient for isopyonic separation due to short path length. It is widely used in plasmid, DNA, RNA, and lipoprotein isolation. It is very important to take care of centrifuge while handling the instrument. It is important to ensure that centrifuge blows and tubes are dry. Ensure the spindle is clean. Use matched set of tubes, buckets, and other equipment. Always use safety and centrifuge caps to contain potential spills and prevent aerosols. Inspect tube and container for cracks or flaws before using them. Avoid overfilling tubes or other container. For example, in a fixed angle rotor, centrifugal force may drive solution upside of the tube and container wall. Ensure that rotor is properly fitted on the drive shaft. Make sure tubes or containers are properly balanced in the rotor. Only check O-rings on a rotor if you are properly trained. Apply vacuum grease in accord with the manufacturer's guidelines. Do not exceed rotor maximum run speed. Close the centrifuge lid during operation. Make sure that centrifuge is operating normally before leaving the area. Make sure that rotor has come to complete stop before opening the lid. When centrifuging infectious material, wait for 10 minutes after rotor comes to complete stop before opening the lid. If spill occurs, use appropriate decontamination cleanup procedure for spilled material. Record all accident to your supervisor immediately. These are the few references we have used. Thank you.